Hi guys, today we're going to look at simplifying logarithms. We're going to look at questions like this one, for example. If I've got log base 3 of the square root of 3 divided by 9, how can I simplify that? Well, actually, really these questions are more about how we simplify this thing here. Right? And to do that, we need to understand the laws of indices. So we're going to do a quick bit of recap. We're going to try to go over the law of indices again. So on the first laws, if I have got a to the power of x and I times it by a to the power of y, I should get a to the power of x plus y. I add up the powers. Similarly, if I have a to the power of x divided by a to the power of y, then I get a to the power of x minus y. I subtract the powers. If I have a to the power of x all to the power of y, then I multiply the powers. I have a to the power of x, y. Okay, there's three laws there. Have a look at some of the others. If I have a to the power of minus n, then that is equal to 1 divided by a to the n. And if I have a to the power of 1 divided by n, then that is equal to the nth root of a. Now, I'm just going to pause there. I'm not going to go through all of the rules, but what I want to say to you is that frequently people confuse these two laws here, right? So these are the ones that you need to pay attention to memorizing. If you have got a negative sign in the power, then what you have is a fraction, right? 1 divided by a to the power of n. If what you have is a fraction in the power here, right? 1 divided by n, for example, then what you have is a square root or a cube root or a fourth root. Okay, so if it's 1 divided by 2, the square root. If it's 1 divided by 3, it's the cube root. 1 divided by 4, it's the fourth root, right? These are the things you need to distinguish. You've got a negative sign in your power, it's 1 divided by. You've got a fraction in your power, then it's a root of some kind. Okay, so let's go back to our question. We've got log base 3, the square root of 3 divided by 9. How can we simplify what's inside the bracket? Well, we now know, hopefully, that the cube root of 3 could be rewritten as 3 to the power of a half, right? That, in other words, this thing can be rewritten as that. We could do the same thing with 9 as well. How can I write 9 as the power of 3? Well, 9 is 3 squared. Okay? So what I've got now is 3 to the power of a half divided by 3 squared. Well, if that's the case, then what I've got is I've got the second rule I did earlier, a to the power of x divided by a to the power of y is a to the power of x minus y. So I've got to take the power of a half and subtract it, or rather subtract 2 from that, right? So I do a half minus 2. So what will I get here? Log base 3, 3 to the power of half minus 2. What is a half minus 2? Well, it's minus 1.5, right? Minus 1.5, or if you prefer it, minus 3 upon 2. Okay? So then I've got log base 3 of 3 to the power of negative 3 upon 2. So we just need to ask ourselves the question now, if my base is 3, what power do I have to give that in order to get 3 to the power of negative 3 upon 2? Right? What power do I have to give 3 in order to get 3 to the power of negative 3 upon 2? And the answer is minus 3 upon 2, because if you think about it, what I'm really saying is this: 3, the sum power, is equal to 3 to the power of negative 3 upon 2. Well, if that's the case, then surely the power here must be minus 3 upon 2. Okay? So in other words, if you get a problem like this one here, okay, what you want to do is you want to take everything inside the bracket and change it so it's all got the same base as the logarithm. In this case, the base of 3. And once you've got it all into base 3, like we do here, right, then in the end, your answer is going to be whatever your power is there, okay, minus 3. Let's try it with another example. Okay, now here what we've got is we don't have a number for our base. We've got a letter, right? A variable, x. Okay, but it looks more complicated, but really it's not. Let's try to do the same thing. Let's apply our indices laws to what we've got here. Okay, so we have log base x of x to the power of 1. How do I write the square root as a power? Well, I write it as to the power of a half. So I've got x cubed to the power of a half, right? Because power of a half is the same thing as the square root. Okay. How can I apply the law of indices again? I can apply it to this, right? Because if I've got x to the power of 3 all to the power of a half, then I've got to multiply those two powers together. What I should get is x to the power of 3 upon 2. Right? For those of you who aren't quite sure what's happened there, right, this was the third law that we had earlier. If I've got a to the power of x to the power of y, I have a to the power of x times y. Okay, so here I've got x to the power of 3, and then to the power of a half, so I multiply 3 by a half. Okay. All right, let's keep going. So here now what we have is got x to the power of 1 times by x to the power of 3 upon 2. Well, this is the first law that we did. A to the power of x times by a to the power of y is equal to a to the power of x plus y. I add the powers. So what I should have here is log base x of x to the power of 1 plus 3 upon 2. If I do that, that's 5 upon 2 or 2.5, whatever you put. Okay, and so now what we've done is we've changed what's inside the bracket, so it's got the same basic base as the base of our logarithm. We've got to ask the question then, well, what power do I have to give x in order to get x to the power of 5 upon 2? And the answer then, of course, is 5 upon 2. Right? We're just left with the answer being the power that we've got for our indices inside the bracket. Okay, let's do one last one. Okay. So log base y of y to the power of 5 divided by the cubed root of y squared. Looks extremely complicated. It is a complicated example, but again, what we're going to do is we're just going to simplify the indices inside this bracket there. Okay, so how can we do that? Well, the first thing I'm going to do is I'm going to look at that cubed root, right? How can I write the cubed root as a power? Well, as a power, the cubed root is a power of 1 upon 3. Okay, so this is going to be y squared to the power of 1 upon 3. Remember, for those who weren't quite sure, I've got a to the power of 1 upon n. That's equal to the nth root of a. So if I've got a to the power of 1 upon 3, then that's equal to the cube root of a and vice versa. Okay? In other words, I've replaced the cube root with the power of a third. Well, now what I can do is I can continue with the denominator, because I've got y squared to the power of a third, so I can then multiply those two powers together and get y to the power of 2/3, right? Because 2 times by a third is 2/3. Then lastly, if I have got y to the power of 5 divided by y to the power of 2/3, then what I've got to do is I've got to subtract those powers. I get y to the power of 5 minus 2/3. Okay? And we may ask ourselves, what is y to the power of 5 minus 2/3? Well, it'll be y to the power of 4 1/3. Okay? I'll leave you to check that by yourself. Right? Log y, log base y, y of 4 1/3, or if you prefer, 13/3. Okay, so in the end, if what we've got is log base y, y to the power of 13/3, we've got to ask ourselves the question, what power do I have to give our base in order to get y to the power of 13/3? Well, the answer must just be 13 divided by 3. So sorry about that, ran out of space. But this simplifies to give 13 upon 3. And that's our final. Okay, guys, so I hope that was helpful. I think when you're doing these questions, actually, the key to doing them correctly is to remember the laws of indices, right? This is the essence of what you're practicing. You're just applying it in the context of logarithm. So I hope you, I wish you well with your exercise. Please feel free to send a message in the comment section if you found something about this confusing and you want it to be explained further. Just let me know. Okay, take care, guys. I will see you again next time.